Oh, okay. So today we're going to be looking at linear versus exponential functions. So first of all, a linear function typically starts out with y equals mx plus b, where m is your slope and b is your y-intercept. And an exponential function will start out as a times b to the x power. And here a represents the y-intercept, and b is going to be the base, or what we are multiplying by. You'll see that in the coming example. So let's start off with a linear function, just a quick review of Algebra 1. So here we have our input values. Notice we picked values in consecutive order. Okay, that's very helpful that these are in consecutive order. And then here we have our process for our function. Okay, so we're going to go ahead and input -1 in for x. And we're going to get, let's see, -2 plus 3. So we're going to get 1 as our output. So our first point here is going to be -1, 1 for this function, for our table. Plugging in 0. We get out 3. So since this goes with 0, this is going to be our y-intercept, our b value. Okay, so plugging in 1, we get 5 out. So at this point, we can kind of start seeing the pattern. As long as, like I said, these are consecutive numbers, we can start finding the slope. So here where the change in y is 2, and here the change of x is 1. So recall from Algebra 1 that to find the slope, we do rise over run. So our slope here is going to be +2 over +1. So our slope is going to be 2, as we can see in the equation right here. And we can see our y-intercept right here. Following the pattern, it's really easy to fill in our table, as long as these are consecutive. Okay, so let's go ahead and graph this function quickly. So our first point, starting off with -1, 1, 0, 3, 1, 5. You know, at this point, I think I counted up too many. 1, 5. We know the slope is 2 over 1, so we could just go up 2 over 1. Rise 2, run 1. Rise 2, run 1. Since they're both positive, we're going to be going up and to the right. Find yourself a straight edge. Does not have to be a ruler. And we put arrows on the ends because it continues on. And domain, all real numbers, left and right, lowest to highest, all real numbers. Okay, moving on to exponential function. So here we have our equation. So we're going to go ahead and input our values into this equation. So when we evaluate this, and we just studied rules of exponents, so this shouldn't be too difficult for you. 2 to the -1 power is 1/2. 1/2 times 3 is 3/2, or 1.5. Now if you don't know what 2 to the -1 power, you can always use your power table that we made in class. Okay, plugging 0 in. 2 to the 0 power is 1. 1 times 3 is 3. So here's our 0, 3. This is going to be our y-intercept, hence our a value. Okay, plugging the 1 in. 2 to the first is 2. 2 times 3 is 6. 2 squared is 4. 4 times 3 is 12. I'm using order of operations to evaluate this expression, to simplify this. Substituting 3 in for x. Now, before we do the math here, which you've probably already done, let's look for a pattern. So, what is happening to these numbers? Well, a very general answer would be that they're increasing. Is there a more specific pattern that you can see happening? That's correct. They're multiplying by 2. Multiplying by 2, multiplying by 2, multiplying by 2, and again, the x's are consecutive. That's important. So, since we're multiplying by 2, this is going to be our multiplier, known as our base. So our next number would be 24. 2 cubed is 8. 8 times 3 is 24. And so looking at our equation, we can see our y-intercept, which is 3, right here, our a value. And then we can see our base, which is our multiplier, which is 2. Okay, graphing this. So, all right, so you can see your table. So negative 1, 1.5, 0, 3, 1, 6, 2, 12. Okay, so to draw an exponential graph, we're going to start down here with this point. I'm going to start a little bit on the left side of it, and I'm going to curve. It's going to be a very steep curve. It's curving up very quickly, hence the word exponential. And just like with our linear, we put arrows on the ends. So we're going to put an arrow on this end to show that it continues. And this one's going to be curving down and to the left. So we put an arrow over here. Okay? So since we're going left infinitely and right infinitely, we're going to have a domain of all real numbers. For our domain, our range is going to be tricky though, because with exponential functions, there's going to be this thing called a horizontal asymptote. And our horizontal asymptote is going to be related to our k value. Now our k value, if you'll recall from our parameter changes, our k value is the number that moves the function vertically. It translates the function vertically. So up here, we don't have our k value in here, but let's go ahead and write out the parameters so we can see where they are all located. So here's our stretch and compression. Here's our horizontal translation in the exponent with the x, and it's always the opposite. And then our k value is over here on the end. So if we look up here at this equation, our k value on the end is going to be 0. So we're going to have a horizontal asymptote for this. I'm going to abbreviate horizontal asymptote with HA, and it's going to be y equals 0. And remember, this number is going to be related to our k value. So y equals 0, we're going to graph that line right here, and we use a dash line for asymptotes. Okay, and for exponential functions, these basic ones, they will not cross this. So this will keep going, and it'll get close to that line, but never ever touch it. So our range on the low end is going to be very close to 0. And on the high end, it's going to go to infinity. But since we're getting really close to 0, that means we can't include 0 as part of the range. We're just getting very close to it. That's where the asymptote is. So we're going to use a parentheses. Because remember, parentheses means that we're getting close to this number, but we're not including it as part of the range. Okay, I'll see you all in class tomorrow. Hope you're having a good evening.